audible?
Good evening, sir.
Good evening. Am I audible?
Yes, sir.
चलो अभी स्टार्ट करते हैं, आज लेट हो गया. So in last class we have solved some problem related to the uh, microscopic balances. So today we will solve the problem related to the calculation of friction losses in a given circular pipe system. Okay, so we will solve the problem in MKS unit today. So the whatever the syllabus covered till today, that will come in the second exam, second test.
और सर टेस्ट कब रखना है?
टेस्ट आपने डिसाइड किया था ना, मंडे को किया था, मंडे फिफ्थ फिफ्थ को डिसाइड हुआ है.
5 को सर?
हाँ 5 को.
सर 5 को नहीं 7 को.
सर 7 को होगा ना?
7 को, 7 या 5.
7 वेडनेसडे सर. मंडे को तो एक सब्जेक्ट का टेस्ट है सीआरई का.
अच्छा, मंडे ऑलरेडी तुम्हारा टेस्ट है.
हाँ यस सर.
चलो फिर 7 को करते हैं. ठीक है, ठीक है. तो आज तक जहां तक हो जाएगा वो पूरा आएगा. ठीक है, चलो.
ठीक है सर. वैसे टाइमिंग कितने बजे सर वेडनेसडे को?
4 to 6 इवनिंग में.
ओके सर. 4 to 6.
चलो, हाँ. So today we will solve one problem related to the friction losses with pump in the mechanical with pump okay in a system, hydraulic system, that you have to calculate. So suppose you have a two reservoirs. So this is the first reservoir. It is filled with the fluid. Suppose the fluid is water. Now the fluid is pumped through this reservoir to by using a pump. This is a pump. So this pump flows the fluid to another reservoir. Okay, the dimensions of the systems are given. This length is 5 meter. Here to here, the length is 5 meter. From this point to this point, this length is 50 meter. Now the elevation is, from this point to this point, the elevation is 15 meter. Then after elevation, the size of pipe is this pipe is 100 meter. So this is tank 1, this is point 1, this is point 2. So you are pumping the fluid from point 1 to point 2. Okay, the dimensions are given for pipe dimensions. Here the pipe size is 4-inch pipe. Okay, so this is the 4 inch. 4 inch means nominal diameter, 4 inch schedule number 40 pipe. So I have already explained you how to calculate the schedule number. Okay, how to calculate the dimensions of the pipe by using the schedule number. So problem is given as water at 20 degrees centigrade. Water at 20 degrees Celsius is being pumped from a tank to a elevated tank at at the rate of 5 multiplied 10 to the power minus 3 meter cube per second. So volumetric flow rates are given. Okay, so volumetric flow rate is at rate of 5 multiplied by 10 to the power minus 3 meter cube per second. Okay, all pipes are 4-inch 40 schedule pipe. Four-inch schedule number schedule 40 pipes. Okay, the pump has the efficiency of 65%. Of 65%. Now calculate the power requirement or the size of the pump. Basically, which size the pump of the pump you are using, or the power requirement in the pump. Okay, you can in other words you can say the power requirement of the pump. Okay, so what I am doing, I will do the mechanical energy balance between these 2 points, point 1 and point 2. Okay, first I will do the material energy balance between these 2 points. Okay, so the equation will written as one by 2 alpha V2 square minus V1 square velocity, that is the average velocity. V1 V2 are the average velocities, plus G Z2 minus Z1. This is the potential energy. These are the kinetic energy. V2 square minus V1 square. This is the kinetic energy, plus pressure energy. P2 minus P1 divided by rho. This is the pressure energy, plus sigma F, the friction losses, plus WS. WS is the power requirement, that should be equal to 0. Okay, so what you have to calculate? First you have to calculate the friction losses. That is important. Okay, so for friction losses, first thing you have to remember about the Reynolds number. Whenever you solve any problem related to the fluid mechanics, when the fluid flows in the pipe, the first thing you have to calculate the Reynolds number, because Reynolds number tells you that which region the fluid is happening. It is the laminar region or the turbulent region. Based on that, you can define the value of alpha also. Okay, and the other parameters are also you can calculate from that parameter only. Okay, so the water properties, density of water at the 20 degrees Celsius, you can take from the data book or the data book or the appendix, that is 998.8 2 kg per meter cube. The viscosity of water at the 20 degrees Celsius, this is 1.005 multiplied by 10 to the power minus 3 Pascal second. Okay, so this is all the MKS units. Third is the pipe dimensions. So pipe is given as 4-inch 40 schedule pipe. So 4-inch 40 schedule pipe. If you check the dimensions of this pipe in the data book, you will get value of D equal to 0.1023 meter, or area equal to 8.219 multiplied by 10 to the power minus 3 meter square. Okay. Now you can calculate, once you know the area, you can calculate the velocity inside the pipeline, because water is incompressible fluid, so the velocity will not depend upon the pressure, it will remain constant. So Q, value of Q is given here, Q equal to 5 multiplied by 10 to the power minus 3 meter cube per second. So the velocity of the water inside the pipe that is equal to Q divided by A, means 5 multiplied by 10 to the power minus 3 divided by A, 8.219 multiplied by 10 to the power minus 3. So velocity that is represented by V. So V equal to 0.6083 meter per second. This is the velocity of the water inside the pipeline. Now you can calculate the Reynolds number, NRE, that is equal to dV mu by rho. So all values are written here. You have to just substitute the values from the above mentioned quantities. 1.01023, that is the value of diameter of the pipe, multiplied by 0.6083, this is the velocity, multiplied by 998, that is dV rho by mu. Okay, this is the Reynolds number equal to dV rho by mu. (998.2) divided by mu, viscosity 1.005 multiplied by 10 to the power minus 3. Once you solve this expression, you will get 6.181 multiplied by 10 to the power 4. This is the value of Reynolds number. So it is in the turbulent region. So flow is turbulent. Why you have to calculate that reason? Because you have to first calculate the major loss. So major loss is skin friction loss, or for skin friction loss, if it is a turbulent, then you have to calculate the value of the value of friction factor based on the Moody's chart. If it is the laminar region, then you can directly use the Penning friction factor. Okay, so that's why you have to first calculate the at which region it is coming. So it is coming in the turbulent region. Okay, now we will calculate the sigma f, the total losses, friction losses. Friction losses in the system. So first we will see what are the losses, what are the different types of losses happening in the system. Okay, so first is skin friction loss. that is due to the roughness of the wall, the friction which is created by the exerted by the wall on the flowing fluid, that is the skin friction loss. This is also the major loss in the system. The second type of loss is when the fluid, because we are doing the balance between point 1 and point 2. So fluid is entering from this point to this point. So here the flow channel is contracted. Okay, here the flow channel is contracted. So contraction at the entering of the fluid from the tank 1 to the pipeline. Okay, so contraction due to contraction in flow channel. Okay, we will do one thing. First, we will calculate the skin friction loss. First, we will calculate the skin friction loss. Then we will write the other type of loss. That will make much better sense. So first, we will calculate the skin friction loss. Then we will calculate the other losses. Okay. So the skin friction loss is, this is the turbulent region. So turbulent region, you have to go to the Moody's chart. Okay. So the equation is friction loss F can be calculated as 4 multiplied by F multiplied by delta L divided by D V square by 2. This is the amount of friction loss occurring in the system. Okay, F value will calculate it from the Moody's chart. Okay, so here the pipeline, it is given that you have the pipeline of the schedule number 40, and suppose it is a cast iron pipeline. So for cast iron, the value of psi, that means the roughness factor, because when you have the turbulent regions, you should know the roughness factor. So roughness factor is given here. So roughness factor equal to 4.6 multiplied by 10 to the power minus 5 meter. This is the roughness factor. Then you have to calculate the psi by d. So psi by d equal to 4.6 multiplied by 10 to the power minus 5 divided by d. D value is 0.1023. So that is equal to 0.00046. 0.045. This is the value of psi by d. Now NRE value, you have calculated the Reynolds number value before. So Reynolds number value is already known. That is equal to 6.181 multiplied 10 to the power 4. 6.181 multiplied by 10 to the power 4. That is the Reynolds number value. Okay, so now you can use the Moody's chart. So how use the Moody's chart? Basically, in the Moody's chart, that is the log chart. At y-axis, you have the logarithmic value of f, small f. At x-axis, you have the NREs. Then you have this type of curves, which represent the different type of psi by d values. Okay. So suppose this is the psi by d equal to 0.00045. So just move from the NRE value 1.181 multiplied by 10 to the power 4. Take this value, goes up to the psi by d value, then move in the horizontal direction. You will get the value of f. Okay, so this is the value of f. So take the value of f, substitute here. So value of f will come as 0.0015. This is the value of f at this Reynolds number and psi by d value. Okay. Now, once you know the value of f, you have to substitute the values in this equation. So what is the delta L? Delta L is the total length of the pipe. Okay. So this is the 5 meter, this is 50 meter, this is 15 meter, this is 100 meter. So the total length of the pipe is delta L equal to 5 plus 50 plus 15 plus 100. So that is equal to 170 meter. Just substitute delta L equal to 170 meter. D and V square value is V value is already known. So just substitute the value in the equation. So you will get the friction factor 4 multiplied by 0.0015 multiplied by delta L by D. Delta L is 170. D equal to 0.1023 multiplied by V square. So V value is given here. V value is calculated as this is the V value 0.6083. Okay, so 0.6083 square divided by 2. Okay, so this is the delta F. So it will come as 6.272 kg per joules per kg. Okay, this is the unit of the friction factor. Okay, now once you know the friction factor, then you have to calculate the other losses. Okay, so this is the major loss which occurs in the system. The other losses are first loss, the minor losses, है ना? Now the minor losses. So in minor losses, first loss is the when fluid enters from tank 1 to pipeline. At this point, you have the sudden contraction. In the pipeline. Okay, so that at this point you have the loss. So what is the formula for the sudden contraction? In the sudden contraction, first you have to calculate the friction factor formula, that is equal to KE. KE equal to 0.55 multiplied by 1 minus A2 by A1, where A2 is the dimensions of the input, A1 is the downwards, A1 is downward flowing channel dimension, A2 is the upward flowing channel dimension. Okay, so in this case, upward flowing channel dimension is because this value is much greater than this value. So you can assume this value is negligible in comparison to this value. Okay, here the dimensions are much higher because the size of the tank is much greater than the size of the pipe. Okay, so in this case, A2 is the dimension of the pipeline, even cross-sectional area of the pipeline, cross-section area of pipeline, and A1 is the cross-sectional area of tank. Okay, so because tank size is much greater than the pipe size, this value is almost 0. Okay, so you can say K equal to 0.55. Okay, just substitute value in the equation. So H equal to friction loss equal to KE multiplied by V square by 2. Alpha value is 1 due to turbulent flow. For laminar flow, alpha is 0.5. For turbulent flow, alpha is 1. Okay, just substitute the value of K is 0.55 multiplied by V square. V value is 0.6. What is the value of V? 0.6083 square divided by 2. When you solve, the value will come 0.102 joules per kg. So this is the friction loss which occurs when the fluid enters in the pipeline. So when the fluid enters from this point to this point, there is a sudden contraction. That's why you have the friction loss. Now you have the two 90-degree elbows. This is the first 90-degree elbow and this is the second 90-degree elbow. Okay. So in 90-degree elbows, you have the friction losses. Okay. So you have to calculate the friction losses in the two 90-degree elbows. Okay. Now the next minor loss is, second minor loss is two 90-degree elbows. Okay, so for elbows, Kf value is defined from the data table. You can take the value of Kf, that is 0.75. It is given in the data table that for elbows the friction factor value is 0.75. You have to just substitute the value. So Hf equal to, because this is the 90-degree elbows, so 2 multiplied by then Kf value is 0.75 multiplied by V square by 2. Okay, so just substitute the value of V square, 0.6083 square divided by 2. You will get the value of Hf, that is 0.2278. Okay, so here all values are, this is the He, this is Ff. Okay, so everything has the different notations. Okay, now the third type of minor loss is, third type, that is when fluid enters from the pipeline to the tank 2. When fluid enters from pipeline to tank 2. So at this point, you have the sudden expansion. Okay, so for sudden expansion, you have the formula Kex, that is equal to, in bracket, 1 minus A1 square divided by A2 square. Where A1 is the diameter of pipeline, not diameter, cross sectional area of the pipeline, and A2 is the cross sectional area of the tank. So A1 is far less than A2. So you can say this quantity will be near to 0. So Kex equal to 1. Now substitute you have to calculate Hex. So Hex equal to Kex multiplied by V square by 2. Just substitute the value of Kex equal to 1 multiplied by 0.6083 square by 2. You will get the Hex, that is equal to 0.185 joules per kg. Okay, now you can calculate the total friction loss. Okay, so now total friction loss, that should be equal to sigma f, that is equal to ff plus, that is the major loss due to the skin friction. Second is the He, third is the Hf, and fourth is the Hex. Okay, Ff plus He plus Hx plus Hex. Okay, so these are the four losses. So Ff value is calculated as 6.272 plus He value calculated as Ff value here 6.272, then He value calculated as 0.102, so 0.102 plus Hf, this is Hf. Okay, now Hf value is calculated as 0.278 and Hex value is calculated as 0.185. Now the total energy loss is 6.837 joules per kg. Okay, now just substitute this value in the original equation. Okay, so in original equation, the Bernoulli equation, V2 and V1 are 0. Why V2 and V1 are 0? Because the size of tanks are very large. So at this point, at point 1 and point 2, the velocities will be relatively negligible. Okay, because for a huge size of tank, it is very the velocity at the inside the tank will be very less. Okay, only in the pipe you have the very high velocity. In the tank you have very low velocity. Okay, so Bernoulli equation, V1 equal to V2 equal to 0. So kinetic difference in the kinetic energy will become 0. First I will write the equation so you can again understand this. So the equation will be V1 square minus V2 square divided by 2 and the Bernoulli equation and G Z2 minus Z1. So alpha will be there, but alpha will not include alpha equal to 1. Then Z2 minus Z1 G plus P2 minus P1 divided by rho plus sigma W, sigma F minus W equal to 0. And force equal to 0. Okay. Now this value is difference in the kinetic energy, that will be equal to 0 because V2 equal to V1. Similarly, you can also say P2 minus P2 equal to P1 because both are in the atmospheric pressure. Okay, so this point and this point, 1 point and 2 point, both are in the atmospheric pressure. So pressures are equal in these 2 points. So you can say pressures are equal. So P2 minus P1 equal to 0. Z2 minus Z1, it is given in the equation, that is equal to 15 meter. Okay, Z2 minus Z1, it is given here as a 15 meter. So you can use the 15 meter. So 15 multiplied by 9.8 plus sigma F. So sigma F value, this is the plus, and because the pump will add the energy. Sigma F is 6.837 plus Wf equal to 0. So once you solve this equation, Wf equal to minus 153.93 kg per joules per kg. Okay, so this is the amount of energy, joules per kg, specific energy required for in the pump. But you have to calculate the power requirement, and for power you have to convert the joules per kg to the joules per kg to the joules per second. Okay, or the watt. So how to convert the joules per kg to the joules per second? For that you have to multiply the power requirement equal to that should be equal to energy requirement, specific energy consumption, or the specific energy requirement multiply by specific energy requirement multiply by mass flow rate. And mass flow rate equal to volumetric flow rate multiplied by density. Density. So volumetric flow rate is 5 multiplied by 10 to the power minus 3 meter cube per second multiplied by density is 998.2 998.2 kg per meter cube. So once you solve this, this will come 4.991 kg per second. This is the mass flow rate. So you can take the mass flow rate and calculate the power requirement. So the power requirement is 4.991 multiplied by specific energy requirement, that is the 153.93. This is the specific energy requirement, and then divide the efficiency of the pump. Okay, so here you have to divide the efficiency of the pump. So that is 65%, means 0.65. Okay, so you will get the actual power requirement. So it will come 1182 joules per second. So joules per second means watt. 1182 watt, or you can say 1.182 kilowatt. So at least you have to use 1.5 kilowatt, because either you have the 1 kilowatt pump or the 1.5 kilowatt pump. So you have to use at least 1.5 kilowatt pump in this case, or you have to use actual power requirement is 1.182 kilowatt in the pump. ठीक है, और कुछ पूछना है आप लोगों को? आया समझ में ये?
सर
हाँ बोलो।
सर वो सिलेबस स्टार्ट कहाँ से होगा जो टेस्ट में आने वाला है? इक्वेशन ऑफ मोशन।
हाँ, इक्वेशन ऑफ मोशन से स्टार्ट होगा, उससे पहले भी आया था टेस्ट वन में।
उससे पहले कंटिन्यूटी आया था, इक्वेशन ऑफ कंटिन्यूटी।
हाँ, वहां तक आया था ना, इक्वेशन ऑफ मोशन
Yes,
से
sir.
अभी तक जितना कराया है वहां तक आएगा,
ओके सर।
है ना। ये न्यूमेरिकल्स करके देखो, इजी है, कुछ नहीं है, फार्मूला बेस्ड न्यूमेरिकल होते हैं ये। इनको मैं और भी मैं प्रैक्टिस के लिए अपलोड कर दूंगा असाइनमेंट, एज असाइनमेंट। ठीक है, तो सॉल्व करके देखो, ये मिल जाएंगे तुम्हें बहुत।
सर और मटेरियल अपलोड कर देना।
हाँ, मैं
सर
अपलोड कर देता हूँ।
और
हाँ
जो
बोलो।
ये जो पीडीएफ जैसा नहीं, जो पीपीटी जिसपे लिखते हो वो वाला अपलोड कर देना।
हाँ, मैं वो करता हूँ अपलोड। चलो,
रिटन मटेरियल।
हाँ, रिटर्न कल सुबह तक मैं कर दूंगा सभी अपलोड। ठीक है,
ओके सर।
चलो। और किसी को पूछना है? तो खत्म करें क्लास अब?
यस सर।